can put it at the end, and then I'll take questions, and then we'll just tag team it. I know there must be a lot of questions, I understand that. And we're trying to do this in a math class in a traditional setting as well. But as Jennifer said earlier, the problem-solving part is the one that we have to teach explicitly. What kind of questions do the kids need to ask? And how do they go about solving those problems? So we're training them like that. Thank you. And
so if we can have people just write down their questions, because some of them might be answered as you're hearing out on the other approaches, and then we'll have about 15 minutes at the end for questions of anybody. Okay, so who's up next?
We have one very eager question.
Oh,
okay.
One very eager question.
What level are you teaching using this?
The 10th through 12th graders, so that's the 16, 17, 18 year olds.
Secondary school for
Secondary school, yes.
I thought from school you do that.
Oh, no.
Yeah, these are all secondary
I'm a
school.
high school teacher. 15 to 18 year olds is what I teach.
Okay?
Okay. Thank you.
Okay, this is where you have that Dr. Bowman as a presenter, where she's done a really good job, and I am a little nervous about what I'm about to present. So basically, she was doing problem-based learning, and as you notice, the duration of that learning was a bit shorter. It was about 5 or 6 days wrapped around a unit in a given project. Now, the next type of project we'll talk about is going to be working in a creative challenge. This is one where it can be anywhere between 3 to 8 weeks, and instead of having more of a specific question, we're going to give them some type of driving question. Now, before I go into this, I'm about to give you some materials that are very guiding for the student. Much more guiding than you might think really is authentic project-based learning. But as we saw today in the keynote, there's kind of a spectrum. There's a spectrum between starting and being a little bit more direct to prepare the kids and let them start to build the skills, to being much more student-centered, less direct, much more guiding, or much more student-guided. And so what you're going to see here is a unit we do at the beginning of the year, where we're really guiding them through a problem-based or project-based learning experience. And then as we go throughout the year, we give them more open-ended. Yes? Okay. Are you going to hand out for me? Very cool. So this is a project that we first implemented this year, and it's all wrapped around general chemistry and specifically gas laws. And gas laws is kind of unique because it's also something that you can do in a physics class, and there's a lot of applications to this given project. We have our physics teachers actually asking us if they can expand on this and start doing some other things like Bernoulli's principles and other things that could be put around like aeronautical engineering, etc., that they're going to teach in the class. So I want to just highlight the first page you have is once we initiate the project, the student would be given this guiding sheet. Okay, so I'm going to just talk briefly how we would introduce this project, and then you can see what the student is given. We would start with a driving question and an entry event. Okay, so this is more of the Buck Institute model. The entry event is an article relative to the new design of the Dreamliner. So as you know, Boeing just came out with a new airplane. They've written a couple articles, and it talks a lot about the experience that students or that people have as passengers and how the Dreamliner is going to improve that experience for the passenger. This is a really good topic for us because many of our students travel a lot. So they've been in airplanes, they've been cramped up, they've been hot, they've been uncomfortable, often for extended period of times. So there's a bit of an empathy factor. They get it, they understand it. And that actually helps with the motivation. So this is why we chose, or this is one of the topics we chose for PBL and chemistry. So the driving question for the student is, how can we improve the atmosphere, in quotes, for passengers in an airplane? Okay? The context is you have to present as a consultant for an engineering firm who's been given the task to actually present these in-cabin atmospheric solutions, where we're going to actually have a fair. You're going to walk up as a consultant, you're going to present your ideas, and you're going to be not only peer assessed, but assessed by teachers and outside people from the public to see how you're doing, okay? So that's your driving question. Now, if you look at the first page, this is the sheet that the students would give. Under the context, you'll see that it says deconstruct and construct. We're actually following an awareness model, a research model that's based on Cambridge International, what's called the critical path. And you can find this on many of their syllabuses that they offer. I think it's the A-levels. If you offer that, your teachers will probably be familiar with this. We chose it because there's a creative piece. There's a piece where they don't have to focus so much on the science as much as looking at it from different perspectives and really try to come up with what's going to be the best solution moving forward for a particular issue. For our issue, it's the comfort of parents. So the students will be guided through, this time, deconstruction, reconstruction, reflection, and communication. Yes? Oh, I'm sorry. Thank you for asking a question. And as I mentioned, our life science courses, when we ask the question about how would you cure cancer, they follow the same process. So we're trying to build this deconstruct, construct, and then reflect and communicate process as the kids go through their high school career, so they get better and better at it. All right? Now, if you turn to the next page, you'll find a Socratic seminar. So, as teachers, we had to create learning scaffolding. What is it we're going to have kids do to be able to learn this material that we think they're going to need as a basis for their understanding beyond what we've called their need to know? And what's interesting, and the reason I include this, is because this is actually a project that we assess collaboration. We do not assess their answer. So we are giving them a question. They have to answer in 45 minutes. No internet, no phone, no book, no notes. They have to use all their prior knowledge of labs and all their experiences with data and discussions that they've had and have to try to answer this question, which if you had your calculator, we actually say no calculators anymore because our new calculators can look it up. It's a very difficult problem for them to overcome. And what I'm assessing, or the teachers are assessing, is actually their collaboration. So most of them will come up with the answer after 45 minutes, but how did you collaborate? So in sharing research, if you turn over the page, that's the rubric we use. Often people say, we assess collaboration, we assess this skill and the ability to work together as a team. This is one of the most effective tools I've seen to date that our school uses to actually be able to assess the collaboration. So if you look at the top, the professional level, those are the 4 items that we find are most essential in the ability to be able to collaborate and work together. All right? I want to use an example of another collaboration technique. We do a lot of modeling in chemistry, so while we're assessing their collaboration and what they're putting together, they then put together whiteboarding. So often they're working in groups, and they are putting together, in this case, these are the other lab experiences they've done, so the relationship of pressure and temperature, the relationship of volume and temperature. So they're doing all these experiences in the collaborative sense, and it culminates into this final assessment as a rubric. Okay, so when we talk about working collaboratively, I think often we just assume that implicitly kids are going to get together, and if they're working well together, great, you get an A for collaboration. But what specifically are we looking for? And so we figured we would share that. Now, so that was the Socratic activity. What's interesting about this project is whenever you do an assessment for a project, you want to use multiple different modes. So do I assess gas laws with a project? Probably with a test. So the mathematical applications, I give them a test. Okay, it's a very traditional format. So what we chose to assess here was their creativity. Remember, this is a creative challenge. And the rubric I've given, it was adopted from Buck Institute, which is adopted from EdLeader 21, which worked with the P21 collaboration. This is a great rubric on product and process for the kids' ability to come up with a creative solution. Not just come up with something mathematical or something they looked up for. And trust me, we had some very interesting solutions. We had some planes that were larger than a cruise ship, so there are some issues with the physics of flying and all that kind of stuff. We had some planes that had all kinds of different amenities, et cetera, in it. But I did want to share some examples in allowing them to come up with something more creative. I'll share it in a minute. So if you imagine at the end, we've assessed this with a test. Our gallery walk presentation, they have to have a visual, something written, and something tactile kinesthetic is optional, and they've got to be able to answer questions. So the teacher is assessing the creativity while the students are assessing the oral component. And so these are some examples. Now there's written pieces, so please understand that the students had to give any type of calculations or graphs or any type of gas law solutions that they've worked out on a separate sheet with their explanations. But these are some examples. And what I found most interesting is once you allow the kids to be more creative, they took it so much further than what I ever expected. They were looking at all the different components of planes. They wanted to change the way the engines work. They wanted to change the way the cabins were set up, where the luggage was placed. They wanted to increase the volume. They wanted to increase humidity, so they figured out how can we capture more moisture from the air. These kids just took it to so many different levels, and all wrapped around this idea of trying to create a better atmosphere, a better what we currently exist under a normal condition at actually at Singapore standard conditions usually. So I thought that was kind of interesting. So as we mentioned before, we're going to hold off for the questions till the end, and I'm going to introduce Martin to do invention based on innovation design. Do you want me to do the? I'll do it. Yeah, we'll do it with you. Sure. Give me a clicker. Just go like this.
My name's Martin. I teach a one-semester elective called Innovation and Design, and it's for students aged grades 9 to 12, age 14 to 18. We're currently on our 4th iteration of this course, and I think fundamentally, if there's one thing the course is about, it's well, two things, but it's about developing creative confidence in the students. And allied to that is the capability to undertake a project challenge of their own at the end of the semester. But I think this one, for me, is really critical. They have these skills here, but if they don't have this, then they won't follow through on these particular projects. And the way in which we do that is using the design thinking process this one's from Stanford University. And the idea here is that we try to cycle the student, or expose them to as many learning cycles as possible. So instead of a lot of larger projects that we would take them through, they tend to be a lot of very quick projects. Some of them, we do a lot of single day ones, quite a few with 2 or 3 days, and I think the longest one that we have at the moment is about 3 weeks. Okay, so just to illustrate that very quickly, this is one that we've just finished. As I said, the content of this, initially it drives the students there, because really the content of this is very processful. All right, we do things that could come under product design, things that I've used, projects I've used in architecture class. There's a very wide range of content material, but essentially I think where we're heading for is more, I think, service design and service processes. So this is one that we've just recently had. We get a lot of, we're a school of 4,000, we get a lot of new students in high school every year. So this is a project that I found is really successful. And the way in which we start this off is to frame the question in terms of redesigning the experience of being a new student. And I think where that's different is in a traditional design course, we might have, the STEM sentence might be design a better. But I think what we try to do is broaden the frame for our initial design challenge, and so that students actually get to choose the problems themselves. And the way they do that is we're in teams of 3 or 4, they're given a large whiteboard, and they probably spend 4 maximum of 5 lessons in which they basically do a deep dive. In here, this particular one, I've got various templates that I use. This one's we refer to as an empathy map. The students here in this particular example decided to create a timeline. And with positive experiences on the top half, negative experiences on the bottom half. And their timeline starts from the very first day that students hear that they're coming to the school at SAS and finishes at the point where the students feel that they're actually integrated in SAS culture. And they would interview somewhere between 10 to 20 different students, a range of different students. And what the objective behind this is that eventually what they're going to do as a team, they're going to focus on one specific aspect of that new student experience. And they will actually define the problem themselves. Okay? They will find some part of that experience that they believe can be innovative, or in terms of a product, or in terms of the process. And that's purely down to them. I have no influence at all in that. And sorry, this is the second stage, is the definition. And then from there, what they would do is, in their teams, they're asked to come up with a range. Usually we say a minimal amount initially of 10 different solutions of trying to solve that problem. And initially what I will always do is give them a range of different media that they need to find solutions for. And then following that, they will eventually hone in on sort of a final solution in which they will sort of a cycle of testing and prototyping. So they may initially hone in on 3 solutions. They will build small prototypes with those. Even for service, they still have to prototype a service. And they will then, because of the research they do and testing with their audience, they will hone in on a sort of final solution for that. Okay. And ultimately, these are they're presenting the real audiences. So in this example here, their audience was the counselling department. And we've done this particular project twice now, and I think three of the projects have actually become recommendations that are being incorporated into the new student experience at the school. So they have a real audience. And just to sort of finish up, I mean, this is new. It's new. I said it's new for me, and there's still quite a few things I'm sort of grappling with. I think the one is identifying small, authentic projects where we can scaffold the skills. There's got to be a degree of authenticity to it. There's got to be a degree in which there are problems or challenges that are relevant to them to get their interest up. I find when they're teacher-directed things that I present to them, the motivation levels drop considerably, and you don't get the same degree of buy-in. Whereas on the other hand, if it's something they're really excited about, you can really sort of challenge them to develop a whole range of skills around that. The second thing is the content. That seems to, I suppose where I think we're heading for is having really more a service, calling this a service design, because the service aspect of it seems to provide a lot of very tangible projects which the students are interested in. The grade level is another question I have. The span of age groups that we have for this at the moment, I think for me is a little bit problematic, the maturity levels of a 14-year-old versus an 18-year-old. Because ultimately, where we want to be for me as the end of the semester is that students are actually pursuing within their team a project of their own choosing. And I find that's very easy for the 18-year-olds, but for the 14-year-olds that can be more problematic. And the last one there is always the other thing is, in terms of the final assessment, there is to what extent should I be providing the projects for them versus them actually going out and choosing them themselves. And that in a nutshell is that.
Okay, so now that you've heard about 3 different specific examples, if you could take just a minute or 2 to reflect back on the 3, and what are questions that have emerged for you? And I want to give you some time to process and to think of your questions, and then you'll have the opportunity to pose it to the 3. And the questions might be around real specifics, or the questions might be more around what have you found with this or that, challenges, that kind of thing.
We just have 2 minutes. Can I just mention one thing? Okay. This morning in the keynote, it was discussed that capstones are not PDL. Did you guys pick that up? That was shocking to me. And I wish that I could kind of sit down and have a discussion over coffee about that. Because ultimately, we're going to culminate our student experiences with a capstone at the end. And our perspective is, it's the ultimate PBL experience, where kids are going to use the design thinking and that empathy, come up with their own driving question. They're going to be to their own need to knows. And we're going to be really only looking at skills as they learn something that's rich based on their interest and passion. So I want to throw that out there. I don't know if that felt uncomfortable to you, but I would love to have dove a little bit deeper into the reasoning for that. So I'll throw that out there before the Q&A.
Seth, if you wanted to, again, just take a few minutes to process. I know some people like to process with the partner, other people like to process individually, up to you. And then we'll open it up for questions, either about a particular project you heard about or just overall our experience.
It's a great question and something we need to address as tonight.
Okay, so we'll give it about 34 seconds and then we'll open it up for questions. Like all people are ready. Okay, so we know that there's at least one question because that started to be asked to us. So why don't we start with you?
How frequent you all change the questions or redesign the questions? How frequent?
For myself. So in our class, we do 6 units in total. Yeah, so 3 units per semester, and the idea of the semester, we start in August, like mid-August, that goes all the way to the mid-December, and we do 3 units. The project that you saw took about 4 to 5 weeks because I presented as 6 days because those are the 6 days that students spend in class in order to work on their project. But we still have the tests and quizzes and checkpoint days. So in total, that actually took about 4 to 5 weeks. The project that just got finished this past week was not like that. It was a statistics project, and that took 8 weeks. So.
But do you essentially keep the same question that you just repeat each year?
Oh.
So like the one
yes,
that you
but then we tweak it. So we took the question. So the math art, for example, we did present it last year, and then this year was a little bit different. The rubric was a little bit different because we got better at anticipating what the students were going to ask, the questions, and some of them wanted to do like a smiley face, and then we said, well, that no longer will be okay. You have to draw more than just a smiley face, for example.
And how about let's say the Dreamliner, right? Do you reuse the questions?
Once again, it's for us, we have something called PLCs, professional learning communities, and we meet once a week. So when we did this unit, we meet beforehand. As we cover the unit, we constantly look at what's happening in our classes and give each other feedback. And then at the end, we then assess the learning experience, look at the data the kid's learning, and say, should things be changed? This one was pretty successful, especially given the more structured approach. The one with the cancer, I can tell you that after the first year, we switched it. Because we started out with like communicable diseases, it became this wild animal, and it wasn't, we couldn't hone it into some of the content we need to cover. Not that content's the most important, but it was out there. And then we kind of reassigned it and prioritized it to be in the mitosis cycle. And then we changed it to a cancer question. So that was 1 year, it's changed. This one we're probably going to tweak a little bit to look at the internal cabin environment, not just the overall atmosphere. So I would say that one's just tweaked. Yeah, so it depends on the project and the success.
So essentially in our system, the way we have it set up is every teacher's a part of a professional learning community, no matter what level they're teaching at. And so those decisions about keeping questions or changing questions are really a collaborative conversation that happens based on the feedback that they've gotten from the unit. So there's not a cut and dry, you only can use this one time and it's gone, and you can use this 3 times.
How do you actually handle the assessment part of it? Because for normally you have things like invention and creative challenges. You encounter students repeating the common ideas that the past students have created. Maybe it may be their own original idea, it's just that because in our society is so globalized, everybody is thinking about the same thing and the same solution, they somehow get influenced and wanted to do the same thing. Then how do you handle this, and also to give a fair assessment of the student, because students, there are always a group of students who wants to do well.
How do you keep it fresh and not have students use other people's work?
And also,
in a sense,
how do they do well if they want to do well?
Okay, what do you think, Martin?
Because it's entirely process driven, at least for us, every stage of that process, I've got a visual documentation often in terms of what they're doing. And I very rarely, with this process, very rarely get students are even honing in. They don't have the same design questions for me. So, I can't ever remember a situation where 2 students are actually, they've got a similar, the solution at the end is anyway similar, because they're choosing a different, I'd be a bit highly suspicious if they had the same design challenge that they were setting on themselves. It's a little bit different from it.
I think part of the answer to that also is we're a member of a consortium called M2U00129, which is out of the United States, and they've done a lot of work on how to assess collaboration, communication, critical thinking, and creativity. And like if you look at their creativity rubric that they have, there's one component of it that's kind of like original thought, but there's other parts to the creative process that are equally important. It's being able to take this, it's being able to get that feedback. And so it's helping to assess kids beyond just what their solution is, but it's the process of being creative as well and giving kids feedback along that. So I think it's the combination of the design of the project and making sure that there's the focus on the process, not just the final product, that helps to counteract. Though it is always a challenge, especially when you have, our grade is 300 kids, and when you have 300 kids doing essentially the same Dreamliner project.
Right. For us, the Dreamliner, we want them to think out of the box. So creativity is most important, and they love it. They embrace it. Because they know they're going to be assessed on the other pieces for that logic base that they need to have. I would say we do another one at the end of the year, which deals with stoichiometry and titration and acid-base and solution chem. That one is much harder, and we have to be more directed in giving them a list of multiple kind of experiences that could guide them. Using an acid-base titration to do a product assessment. So we try to really guide that a little bit more. But also that collaborative piece is really important. The number of times we've sat down at a table to compare projects, that looks very similar to one that was just handed in to me yesterday, So that it's just an ongoing.
Because of the assessment issue, so sometimes you